Hello, I'm SA, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
For al-Sufi, the celestial sphere is understood through systematic observation and cataloging, owed a considerable debt to Claudius Ptolemy's Almagest. This second-century compendium, a cornerstone of astronomical knowledge for centuries, presented a geocentric model of the universe and meticulously documented over 1,000 stars, providing their celestial coordinates and brightness estimations. Ptolemy's work, while groundbreaking, was not without its imperfections, errors in measurement, limitations of observational instruments, and the gradual shift in star positions due to the precession of the equinoxes introduced inaccuracies over time. A need existed for a revised and updated star catalog, one that addressed these shortcomings through fresh observations and critical analysis. Al-Rahman al-Sufi, a 10th-century Persian astronomer, stepped into this role, leaving an enduring mark on the field with his Kitab al-Kawatib al-Tabidar al-Musawwara Book of Fixed Stars Al-Sufi's Book of Fixed Stars stands as a monumental achievement in observational astronomy, representing a significant advancement over Ptolemy's earlier work. He embarked on a comprehensive project to re-examine and refine the existing astronomical knowledge, driven by a commitment to accuracy and a desire to provide a more complete depiction of the night sky. His approach involved a meticulous process of independent observation, critical comparison with Ptolemy's data, and the incorporation of traditional Arabic astronomical knowledge. The result was a stark catalog of unparalleled detail and precision for its time, one that corrected errors, expanded upon existing descriptions, and introduced new insights into the nature of celestial objects. A prime example of al-Sufi's contribution lies in his description of what is now known as the Andromeda Galaxy, designated M31 in the Masseter catalog. Ptolemy's Almagest makes no mention of this prominent galaxy, rendering it absent from the Western astronomical record until al-Sufi's meticulous observations. In his Book of Fixed Stars al-Sufi describes Andromeda as a small cloud, a faint nebulosity located near the constellation Andromeda. This represents the earliest known written record of the Andromeda Galaxy, predating its rediscovery by European astronomers by several centuries. His observation, though lacking the resolving power to discern individual stars within the galaxy, demonstrates his keen eyesight and his dedication to mapping the faintest objects visible to the unaided eye. The fact that he included this small cloud in his catalog, despite its diffuse appearance, underscores his commitment to completeness and his recognition of its unique nature. One might even say that al-Sufi's inclusion of this small cloud was a bold act of astronomical accounting, meticulously documenting every observable feature of the night sky, even those that defied easy categorization. Beyond the identification of previously unrecorded objects, al-Sufi's work also involved a critical evaluation of Ptolemy's star positions and magnitudes. He recognized that the positions of stars had shifted over the centuries due to the precession of the equinoxes, a phenomenon that causes the apparent slow wobble of Earth's axis. To account for this, al-Sufi meticulously recalculated the celestial coordinates of stars, providing more accurate positions for his time. He also refined Ptolemy's magnitude estimations, offering his own assessments of stellar brightness based on direct observation. These refinements were crucial for improving the accuracy of astronomical calculations and for providing a more reliable basis for celestial navigation. Furthermore, al-Sufi incorporated traditional Arabic astronomical knowledge into his Book of Fixed Stars enriching the catalog with indigenous star names and law. Many of the star names we use today, such as Aldebaran from the Arabic Aldebaran meaning the follower, and Betelgeuse, derived from Ibn al-Jawzar meaning the shoulder of the giant, had Arabic origins, reflecting the significant contributions of Islamic astronomers to the field. Al-Sufi's catalog preserved and disseminated these names, ensuring their continued use in astronomical discourse. He not only documented the classical Greek constellations, but also integrated them with the existing Arabic understanding of the stars, creating a synthesis of astronomical traditions. The enduring legacy of al-Sufi's Book of Fixed Stars extends far beyond its immediate impact on Islamic astronomy. His meticulous observations, his critical analysis of existing data, and his incorporation of Arabic astronomical knowledge laid the groundwork for future generations of astronomers. His catalog served as a valuable resource for celestial navigation, timekeeping, and astronomical research, influencing the development of astronomy in both the East and the West. The Book of Fixed Stars became a standard reference work, copied, translated, and consulted by astronomers for centuries. Its influence can be seen in the subsequent development of star charts, astronomical instruments, and celestial models. The following discussion will delve into the specific observational techniques employed by al-Sufi in the creation of his Book of Fixed Stars It will explore the instruments he likely used, the methods he developed for correcting star positions, and the accuracy of his magnitude estimations. A detailed analysis of his methods reveals the depth of his scientific rigor and the ingenuity of his approach to observational astronomy. Following this, the essay will examine the direct influences on al-Sufi's work, tracing the intellectual lineage that connects him to earlier astronomers like Ptolemy. It will also explore the impact of al-Sufi's work on later Islamic astronomers, highlighting the ways in which they built upon his findings and expanded upon his methods. Through a careful examination of these influences, a clear understanding of al-Sufi's place within the history of astronomy can be attained. Finally, the essay will consider the modern relevance of al-Sufi's work, examining how his contributions continue to inform and inspire astronomical research today. While modern astronomers have access to far more advanced technology, the fundamental principles of observational astronomy remain the same. Al-Sufi's dedication to accuracy, his commitment to independent observation, and his meticulous documentation of the night sky serve as a model for astronomers of all generations. His work stands as a testament to the enduring power of human curiosity and the relentless pursuit of knowledge about the universe. The very act of stargazing, a practice as ancient as humanity itself, finds refined expression in al-Sufi's work, one that continues to resonate with astronomers and enthusiasts alike. Al-Sufi's enduring legacy rests significantly on his meticulous observational methodology, particularly evident in his magnum opus, the Book of Fixed Stars. This catalog represents represents far more than a mere compilation of existing knowledge. It stands as a testament to his dedication to independent verification and refinement of astronomical data. To fully appreciate the significance of his work, a detailed examination of his observational practices is required. Al-Sufi, like many astronomers of his era, relied on instruments such as astrolabes and quadrants for his observations. The astrolabe, a versatile analog computer, allowed him to measure the altitude of stars above the horizon and to determine the time. Quadrants, typically large, quarter-circle instruments, provided more precise measurements of angular distances between celestial objects. These instruments, while sophisticated for their time, possessed inherent limitations. The accuracy of altitude measurements was affected by atmospheric refraction, the bending of light as it passes through the Earth's atmosphere. Furthermore, the precision of angular measurements was limited by the size and calibration of the instruments, as well as the observer's visual acuity. Recognizing such limitations, Al-Sufi implemented careful techniques to minimize errors and to correct for systematic biases. A central challenge in positional astronomy during Al-Sufi's time was accounting for the precession of the equinoxes, a phenomenon known since Hipparchus. Precession refers to the slow, gradual shift in the orientation of the Earth's axis of rotation, causing the apparent positions of stars to change over long periods. Ptolemy, in his Almagest, had provided a star catalog based on observations made centuries earlier. Al-Sufi understood that to create an accurate, contemporary star catalog, he needed to correct Ptolemy's positions for the accumulated effects of precession. His method involves applying a consistent correction factor to the longitudes of stars, taking into account the estimated rate of precession since Ptolemy's time. The precise value used for the rate of precession is a subject of scholarly debate, yet his endeavor to update the star positions demonstrates a keen awareness of celestial mechanics and a commitment to providing astronomers with current data. In addition to correcting for precession, Al-Sufi also addressed the issue of atmospheric refraction. He understood that the apparent altitude of a star is greater than its true altitude, especially near the horizon. While he did possess a quantitative model for refraction correction comparable to modern formulations, he likely relied on empirical observations and established tables to estimate the magnitude of refraction at different altitudes. These tables, compiled by earlier astronomers, provided approximate corrections based on the observed behavior of starlight passing through the atmosphere. By applying these corrections, Al-Sufi aimed to improve the accuracy of his altitude measurements and to reduce systematic errors in his star positions. A specific example illustrates the magnitude of Al-Sufi's positional corrections. Consider the star Beta Tauri, also known as Elnath, which marks the northern horn of the constellation Taurus. Ptolemy's Almagest placed Elnath at a certain longitude. Al-Sufi, after accounting for precession and refraction, determined a revised longitude for the star. The difference between Ptolemy's and Al-Sufi's measurements represents the cumulative effect of precession over several centuries, as well as any refinements made by Al-Sufi to account for observational errors. While the exact numerical difference requires careful reconstruction based on the coordinate systems used, such discrepancies highlight the importance of Al-Sufi's independent observations and his dedication to updating existing astronomical data. Beyond positional measurements, Al-Sufi also made magnitude estimations of stars, providing valuable information about their brightness. Magnitude, in this context, refers to a numerical scale used to quantify the apparent brightness of stars as seen from Earth. The brighter the star, the smaller its magnitude number. Al-Sufi adopted Ptolemy's magnitude scale, which divided stars into 6 classes, ranging from first magnitude the brightest to 6th magnitude the faintest, visible to the naked eye. His estimations were based on visual comparisons with known stars of established magnitudes. Comparing Al-Sufi's magnitude estimations with modern measurements reveals a reasonable degree of accuracy, given the limitations of visual observation. While his estimations were subjective and prone to individual variations, they provide valuable historical data about the relative brightness of stars. In some cases, discrepancies between Al-Sufi's magnitudes and modern values may reflect actual changes in stellar brightness over time due to stellar variability or other astrophysical phenomena. These discrepancies, while subtle, offer intriguing avenues for further investigation. Al-Sufi also incorporated color descriptions of stars into his book of fixed stars. While color perception is subjective and influenced by atmospheric conditions and the observer's physiology, his observations provide valuable insights into early attempts at stellar classification. He described certain stars as reddish, yellowish, or whitish, reflecting subtle differences in their spectral characteristics. These color descriptions, while qualitative, foreshadowed later developments in astrophysics, where stellar color is used to determine a star's temperature, composition, and evolutionary stage. His attention to color, even in a rudimentary sense, demonstrates a keen observational sense and a desire to capture the full range of stellar properties. Ptolemy's Almagest served as a foundational influence on Al-Sufi's work. The Almagest provided a comprehensive framework for star cataloging, positional astronomy, and celestial mechanics. Al-Sufi directly adopted Ptolemy's star catalog as a starting point, carefully verifying and updating the positions and magnitudes of stars. He also followed Ptolemy's general methodology for describing constellations and celestial phenomena. The Almagest thus provided the essential scaffolding upon which Al-Sufi built his own astronomical masterpiece. Al-Sufi's observational techniques and meticulous data collection profoundly influenced later Islamic astronomers. His book of fixed stars became the standard reference work, consulted and cited by generations of scholars. Astronomers such as Ulugh Beg, working at the Samarkand Observatory in the 15th century, replicated Al-Sufi's methods, making their own independent observations and refining his star positions. These later astronomers often acknowledged their debt to Al-Sufi, recognizing him as a leading authority in observational astronomy. They built upon his work, improving the accuracy of astronomical instruments and developing more sophisticated techniques for data analysis. The legacy of Al-Sufi thus extends far beyond his own lifetime, shaping the course of astronomical research in the Islamic world for centuries to come. Modern astronomers, equipped with powerful telescopes and sophisticated instruments, employ techniques for measuring stellar positions and magnitudes that are far more advanced than those available to Al-Sufi. Space-based observatories eliminate the distorting effects of the Earth's atmosphere, allowing for incredibly precise measurements of stellar positions and brightness. Spectroscopic analysis of starlight provides detailed information about stellar composition, temperature, and velocity. Despite these technological advancements, the fundamental principles of observational astronomy remain the same. Astronomers still rely on careful measurements, rigorous data analysis, and independent verification to advance knowledge of the cosmos. Al-Sufi's commitment to these principles, evident in his meticulous observations and his dedication to accuracy, continues to resonate with astronomers today, serving as a reminder of the enduring importance of careful observation in the pursuit of scientific understanding. Al-Sufi's legacy extends beyond numerical precision, finding vibrant expression in the star charts and constellation illustrations within his asterisk book of fixed stars asterisk. These visual representations, far from being mere decorative elements, stand as crucial components of this scientific endeavor and offer a unique window into the astronomical knowledge and artistic sensibilities of his time. The artistic merit of al-Sufi's work is undeniable. His illustrations, rendered with meticulous detail and clear aesthetic sensibility, elevate the asterisk book of fixed stars asterisk beyond a simple catalog. They transform it into a work that appeals to both the intellect and the eye. The accuracy of al-Sufi's constellation depictions is particularly noteworthy. While acknowledging the limitations of naked eye observation, his charts demonstrate a remarkable fidelity to the actual positions of stars. Comparing his depictions to modern star charts reveals a high degree of correspondence, particularly for the brighter stars that define the outlines of constellations. He meticulously recorded the positions and magnitudes of stars, enabling him to create constellation figures that closely resembled what observers could actually see in the night sky. The level of detail in his illustrations extends to the rendering of individual stars within each constellation. He carefully distinguished between stars of varying brightness, using different sizes and colors to represent their magnitudes. This attention to detail enhances the scientific value of his charts, allowing users to more easily identify stars and navigate the celestial sphere. The sources of al-Sufi's constellations reveal a fascinating synthesis of Greek and Arabic astronomical traditions. He drew heavily on Ptolemy's asterisk Almagest asterisk for the descriptions and locations of many constellations, adopting the classical Greek figures such as Orion, Gemini, and Taurus. Alongside these Greek constellations, al-Sufi incorporated Arabic star names and traditions, reflecting the rich astronomical heritage of the Islamic world. He provided Arabic names for many stars, often alongside their Greek counterparts, enriching the nomenclature of the constellations. In several instances, al-Sufi introduced new or modified depictions of constellations based on Arabic astronomical traditions. A particularly striking example is his rendering of Ursa Major, the Great Bear. While retaining the overall shape of the constellation, he altered the depiction of the bear's tail, drawing it as a more elongated and curved form, reflecting a common Arabic interpretation of the constellation as a group of stars associated with a funeral procession. This adaptation demonstrates al-Sufi's willingness to depart from strict adherence to Greek models, incorporating indigenous astronomical knowledge to create a more culturally relevant representation of the heavens. He also provides alternative Arabic names and interpretations for certain stars within Ursa Major, further highlighting the integration of Arabic astronomical traditions into his work. The combination of Greek and Arabic knowledge is a hallmark of al-Sufi's work. He skillfully wove together these two distinct astronomical traditions to create a comprehensive and culturally resonant star atlas. He meticulously translated and adapted Ptolemy's descriptions of the constellations, while simultaneously incorporating Arabic star names, folklore, and indigenous astronomical observations. This synthesis reflects the broader intellectual currents of the Islamic Golden Age, where scholars actively sought to integrate and expand upon the knowledge of previous civilizations. Al-Sufi's work exemplifies the spirit of intellectual synthesis, creating a unique and enduring contribution to the history of astronomy. His star charts served as a bridge between the classical Greek tradition and the flourishing scientific culture of the Islamic world, facilitating the transmission and advancement of astronomical knowledge. The artistic influences on al-Sufi's illustrations likely stemmed from contemporary Islamic art and manuscript illumination traditions. The intricate designs, vibrant colors, and stylized depictions of animals and human figures found in his star charts bear resemblance to the decorative motifs prevalent in Islamic art of the period. Manuscript illumination, a highly developed art form in the Islamic world, provided a rich source of inspiration for al-Sufi's illustrations. The use of gold leaf, intricate geometric patterns, and stylized floral designs in manuscript illumination can be seen in the decorative elements of the star charts, enhancing their aesthetic appeal. The precise lines and careful attention to detail in his illustrations reflect the meticulous craftsmanship characteristic of Islamic art. It's plausible that al-Sufi collaborated with skilled artists and illuminators to produce the final versions of the star charts, drawing upon their expertise in design and execution. Al-Sufi's star charts exerted a considerable influence on later cartographers and illustrators, particularly within the Islamic world. His depictions of constellations were widely reproduced and adapted in subsequent astronomical texts, serving as a visual standard for generations of astronomers. Many later Islamic star atlases feature constellation figures that are directly derived from al-Sufi's asterisk, book of fixed stars asterisk, attesting to the enduring impact of his work. The accuracy and detail of his illustrations made them a valuable resource for astronomers seeking to identify stars and navigate the celestial sphere. His star charts served as a template for later cartographers, who often copied his constellation figures and star positions directly into their own atlases. For instance, the asterisk Uranum-Tria asterisk of Johann Bayer, published in 1613, while drawing on European sources, also reflects the influence of Islamic astronomical tradition, indirectly acknowledging the legacy of al-Sufi's meticulous work. While Bayer's work primarily built upon the groundwork laid by figures such as Ptolemy and the more immediate contributions of Tycho Brahe, the underlying structure of stellar classification and the visual representation of constellations owe a debt to the accumulated knowledge preserved and transmitted through Islamic scholarship. including the pivotal contributions of al-Sufi. The transmission of astronomical knowledge from the Islamic world to Europe during the Middle Ages ensured that al-Sufi's insights, though often indirectly, found their way into the broader scientific discourse. The enduring relevance of al-Sufi's work is further underscored by the fact that modern planetarium software and star charts still rely on the same fundamental principles of celestial mapping that he employed. The concept of representing the celestial sphere on a two-dimensional surface, using coordinate systems to locate stars, and depicting constellations as recognizable patterns remains central to modern astronomy. While the technology used to create star charts has advanced dramatically, the underlying principles remain the same. Modern planetarium software utilizes sophisticated algorithms to accurately simulate the appearance of the night sky, drawing upon vast databases of stellar positions and magnitudes. These databases, in turn, are based on centuries of astronomical observations, including those made by al-Sufi and his contemporaries. The constellation figures used in modern planetarium software are often directly derived from the classical Greek tradition as interpreted and transmitted by al-Sufi and other Islamic astronomers. Al-Sufi's commitment to accuracy, his synthesis of Greek and Arabic knowledge, and his artistic skill combined to create a star atlas that has stood the test of time. His asterisk book, Fixed Stars Asterisk, remains a valuable resource for historians of astronomy, offering insights into the scientific and artistic achievements of the Islamic Golden Age. His constellation illustrations continue to inspire awe and wonder, reminding us of the enduring human fascination with the cosmos. The legacy of al-Sufi extends far beyond his specific astronomical observations, encompassing a broader vision of scientific inquiry that values both accuracy and aesthetic beauty. He demonstrated that scientific knowledge can be enhanced through artistic representation, creating a work that appeals to both the intellect and the imagination. The meticulousness of his observations, the synthesis of diverse astronomical traditions, and the artistic quality of his illustrations all contribute to the enduring significance of his asterisk book of Fixed Stars Asterisk. The meticulous observations and artistic representations found in al-Sufi's asterisk book of Fixed Stars Asterisk represent only one facet of his profound engagement with the cosmos. Al-Sufi also dedicated considerable intellectual energy to theoretical astronomy, seeking to refine existing models and deepen the understanding of celestial mechanics. His work in this area, while less visually striking than his star charts, reveals a sophisticated grasp of mathematical principles and a commitment to improving the accuracy of astronomical predictions. Al-Sufi grappled with the complex geometrical models of the solar system and star positions presented by Ptolemy in the Almagest asterisk. Ptolemy's geocentric model, with its system of epicycles and deferents, had served as the dominant framework for understanding the movements of celestial bodies for centuries. Al-Sufi, like many astronomers of his time, recognized the strengths of Ptolemy's system, particularly its ability to predict planetary positions with reasonable accuracy. However, he also identified areas where the model could be improved or refined. He sought to address inconsistencies and complexities within the Ptolemaic framework, aiming for a more elegant and accurate representation of the cosmos. His efforts focused on several key areas. One involved a careful examination of the parameters used in Ptolemy's models, such as the sizes and speeds of the epicycles and deferents. Al-Sufi scrutinized these values, comparing them with his own observations and those of other astronomers, seeking to identify any discrepancies or inaccuracies. He understood that even small errors in these parameters could accumulate over time, leading to significant deviations between predicted and observed positions. Another area of focus involved the arrangement and relationships between the different celestial spheres. Ptolemy's model posited a series of nested spheres, each carrying a planet with fixed stars. Al-Sufi explored alternative arrangements and geometrical configurations, seeking to optimize the model's internal consistency and its ability to explain observed phenomena. He considered the possibility of variations in the distances between the spheres and the relative orientations of their axes of rotation. While al-Sufi did not propose a radically different cosmological model, such as heliocentrism, his work demonstrates a critical and inquisitive approach to the prevailing astronomical theories. He sought to improve the existing framework through careful observation, rigorous mathematical analysis, and a willingness to challenge established assumptions. His work exemplifies the spirit of scientific inquiry that characterized the Islamic Golden Age, a period of intellectual ferment and innovation in many fields of knowledge. Specific examples of his mathematical models and calculations were difficult to reconstruct in complete detail, given the fragmentary nature of some surviving sources. However, it is clear that he employed a range of mathematical techniques in his astronomical investigations. He undoubtedly made extensive use of trigonometry, a field in which Islamic mathematicians have made significant advances. Trigonometric functions, such as sine, cosine, and tangent, were essential tools for calculating angles, distances, and positions on the celestial sphere. Al-Sufi likely used trigonometry to refine Ptolemy's calculations of star positions, taking into account the effects of precession and other subtle astronomical phenomena. He may have also employed geometrical methods to analyze the movements of the planets, seeking to identify patterns and regularities that could be incorporated into improved models. His deep understanding of geometry allowed him to visualize and manipulate complex spatial relationships, a crucial skill for any astronomer seeking to understand the structure of the universe. His potential use of spherical trigonometry is particularly noteworthy. Spherical trigonometry deals with the relationships between angles and sides of spherical triangles, which are triangles drawn on the surface of a sphere. This branch of mathematics is essential for solving problems in astronomy, navigation, and geodesy, as it allows for accurate calculations of distances and positions on the curved surface of the Earth or the celestial sphere. Islamic mathematicians have made significant contributions to the development of spherical trigonometry, and al-Sufi would almost certainly have been familiar with these techniques. The application of these techniques would have enabled him to make more precise calculations of star positions and distances, improving upon the accuracy of Ptolemy's original work. The influence of Ptolemy's Almagest on al-Sufi's theoretical work is undeniable. The Almagest provided the foundational framework for his astronomical investigations, supplying the geometrical models, mathematical techniques, and observational data that he sought to refine and improve. Al-Sufi engaged critically with Ptolemy's work, identifying areas where he believed improvements could be made and proposing alternative approaches. He accepted the basic geocentric framework of the Almagest, but he sought to optimize its internal consistency and its ability to explain observed phenomena. His work represents a continuation of the Ptolemaic tradition, but it also demonstrates a spirit of independent inquiry and a commitment to scientific accuracy. Later Islamic astronomers, such as al-Biruni, built upon al-Sufi's theoretical work. Al-Biruni, a polymath of the highest order, made significant contributions to many fields of knowledge, including astronomy, mathematics, geography, and history. He was demonstrably familiar with al-Sufi's Book of Fixed Stars, and he drew upon al-Sufi's observations and calculations in his own astronomical investigations. For example, al-Biruni used al-Sufi's star catalog to determine the longitudes and latitudes of various cities, improving upon existing methods of geographical measurement. He also cited al-Sufi's work in his discussions of astronomical instruments and observational techniques. Al-Biruni's reliance on al-Sufi's work demonstrates the enduring value of al-Sufi's contributions and the continued relevance of his observations for later generations of astronomers. Al-Biruni's critical examination of astronomical data allowed him to refine geodetic measurements and improve the accuracy of geographical maps, building directly upon the foundation laid by al-Sufi. Al-Sufi's efforts to refine astronomical models contributed to the eventual development of modern astrophysics and cosmology. While his contributions may seem modest in comparison to the revolutionary discoveries of later scientists such as Copernicus, Galileo, and Kepler, they represent an important step in the long process of scientific inquiry that led to our current understanding of the universe. His meticulous observations, rigorous mathematical analysis, and critical engagement with existing theories all exemplify the scientific spirit that is essential for progress in any field of knowledge. His dedication to improving the accuracy of astronomical predictions, even within the confines of a geocentric framework, helped to pave the way for later astronomers who would challenge and ultimately overturn the framework. The incremental improvements and refinements he made to existing models contributed to a growing body of astronomical knowledge that would eventually lead to a more accurate and complete picture of the cosmos. His focus on empirical observation and mathematical precision laid a foundation for future generations of scientists to build upon, ultimately leading to the development of modern astrophysics and cosmology. Al-Sufi's legacy resides in his pivotal role as a conduit between ancient Greek astronomical traditions and the burgeoning scientific inquiries of the Islamic world and, ultimately, Europe. His Book of Fixed Stars stands as a testament to the power of meticulous observation, artistic representation, and mathematical rigor, a synthesis rarely found in such harmonious balance. The book represents a significant advancement in stellar cartography, offering refined star positions, magnitudes, and descriptions that surpassed previous efforts. Al-Sufi's meticulous work on star positions and magnitudes directly influenced later astronomers, both within the Islamic world and in Europe. His redetermination of the positions of stars, accounting for proper motion since Ptolemy's time, provided a more accurate celestial map for navigation and astronomical study. The Book of Fixed Stars became a standard reference work, consulted and copied for centuries. Islamic astronomers built upon al-Sufi's work, refining his observations and incorporating them into their own astronomical tables, such as the Zijai, Sultani Vulubeg. Specific examples of al-Sufi's influence are readily apparent in the adoption of his star names and descriptions. Many star names still in use today, particularly those of Arabic origin, can be traced back to al-Sufi's nomenclature. For instance, the star we know as Fumlahout, from the Arabic Fum al-Had meaning mouth of the fish, owes its widespread recognition to al-Sufi's detailed description and illustration of the constellation Piscis Austrinus. Similarly, the star Albal, derived from the Arabic rise Albal meaning the demon's head, retains the name al-Sufi popularized through his depiction of Perseus holding the head of Medusa. Al-Sufi's contribution extends beyond mere nomenclature. His careful estimation of stellar magnitudes, while subjective by modern standards, represented a significant improvement over Ptolemy's system. He categorized stars into different magnitude classes based on their apparent brightness, providing a more nuanced understanding of stellar luminosity. This work directly influenced later astronomers who sought to quantify stellar brightness with increasing precision. Tycho Brahe, for example, relied on al-Sufi's magnitude estimates when compiling his own star catalog, which was instrumental in the development of modern astronomy. The artistic merit of al-Sufi's star charts also deserves recognition. His illustrations of constellations, depicting both the traditional Greek figures and the Arabic interpretations, are visually stunning and scientifically informative. The combination of artistic skill and astronomical knowledge makes the Book of Fixed Stars a unique and valuable historical document. These illustrations, often copied and adapted by later astronomers, helped to disseminate astronomical knowledge and inspire further exploration of the cosmos. Consider, for example, al-Sufi's depiction of the constellation Andromeda. He portrays Andromeda as a woman chained in accordance with Greek mythology, but also incorporates Arabic astronomical traditions. His detailed rendering of the stars within the constellation, along with their corresponding magnitudes, provides a valuable resource for astronomers seeking to identify and study these celestial objects. This artistic and scientific synthesis exemplifies al-Sufi's unique approach to astronomy. Al-Sufi's lasting impact on astronomical nomenclature, star charts, and methods of observation is undeniable. His work preserved and advanced astronomical knowledge, bridging the gap between the ancient world and the scientific revolution. His meticulous observations, combined with his artistic talent and mathematical acumen, made him a pivotal figure in the history of astronomy. His dedication to accuracy and his commitment to improving existing astronomical models laid a foundation for future generations of astronomers to build upon. The chain of influence from al-Sufi to later European astronomers is complex, yet demonstrable. Translations of the Book of Fixed Stars into Latin, beginning in the 12th century, made his work accessible to European scholars. Astronomers such as Gerard of Cremona played a crucial role in translating Arabic scientific texts, including al-Sufi's Book of Fixed Stars into Latin, thereby transmitting this knowledge to a European audience. These translations, though sometimes imperfect, introduced European astronomers to al-Sufi's refined star positions, magnitude estimates, and constellation descriptions. Later, European astronomers directly referenced al-Sufi's work in their own publications. For instance, the Alphonsine tables commissioned by King Alfonso X of Castile in the 13th century, drew upon a variety of sources, including Arabic astronomical texts. While the exact extent of al-Sufi's direct influence on the Alphonsine tables is debated, the presence of Arabic star names and astronomical concepts within the tables suggests a clear connection. Similarly, the astronomer Johannes Bayer, in his Geonometria 1-6-3, a comprehensive star atlas, incorporated many of al-Sufi's star names and constellation depictions, acknowledging his debt to the Arabic astronomical tradition. Bayer's Geonometria with its detailed star charts and systematic nomenclature, became a standard reference work for European astronomers, further solidifying al-Sufi's legacy. The work of later astronomers, such as Tycho Brahe, also reflects al-Sufi's influence. Brahe, renowned for his meticulous observations and accurate star catalogs, consulted al-Sufi's book of fixed stars when compiling his own data. Brahe's observations, combined with his critical analysis of existing astronomical theories, helped to pave the way for Johannes Kepler's laws of planetary motion and Isaac Newton's law of universal gravitation. Al-Sufi's contributions, though often unacknowledged, played a role in this broader scientific revolution. Even figures like Nicholas Copernicus, while revolutionizing astronomical thought with his heliocentric model, were directly influenced by the traditions of astronomical observation and mathematical analysis that al-Sufi helped to foster. The pursuit of accuracy and precision in astronomical measurement, exemplified by al-Sufi's work, was a driving force behind the Copernican revolution. Copernicus sought to create a more accurate and mathematically elegant model of the universe, building upon the accumulated knowledge of centuries of astronomical observation. Al-Sufi's meticulous observations and careful analysis served as an enduring inspiration for future generations of astronomers. His dedication to accuracy, his artistic skill, and his mathematical acumen represent the best of scientific inquiry. He embodies the spirit of curiosity and the pursuit of knowledge that drives scientific progress. His work reminds us of the importance of preserving and building upon the knowledge of the past, while also striving to improve our understanding of the universe. The value of al-Sufi's contributions extends beyond their historical significance. His work continues to inform and inspire astronomers today. His star charts, though created centuries ago, provide a valuable resource for understanding the night sky. His meticulous observations serve as a reminder of the importance of careful measurement and attention to detail. His legacy as a bridge between cultures and a champion of scientific inquiry endures, inspiring us to continue exploring the cosmos and expanding our knowledge of the universe.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.